Okay, hello everyone. Hope that you can hear me well. So I decided to uh, make these videos going over some more examples that we don't have time to do in class. Uh, I think in fluid mechanics, you need to do a lot of examples. And because we have very limited time, I'm going to do some more examples that I think are interesting and walk you through the solution process and post them on Canvas. So this is the first video. It's from chapter 2, hydrostatic force. So let's read it together and solve it together. So we have this gate ABC that is hinged around B, so it can rotate about B. And it's 2 meters wide into the paper, the dimension we can't see. So each one of these panels is like a rectangular plane, 2 meters wide into the plane. The gate will open if this depth h is high enough. And the question is, what is that minimum h for this to start to rotate? Okay, so basically when this starts to rotate, point A is going to lose contact. Okay, so right at the limit, when this just starts to rotate, when this just loses contact, what is h? So on the left-hand side, I'm showing the free body diagram with the forces acting on this gate. There's no mention of mass or weight, so we can just ignore it. We have hydrostatic force, of course. We know any submerged area is going to have some force acting on it due to hydrostatic pressure. So there's a force acting on this BC plane. I'm calling that FBC. This is from the fluid. We also have the AB plane. So there's a FAB acting on it. Also, there's a reaction force at B, which I don't know. It has some X and Y components. I'm just going to write it as BX, BY. But there's no normal force at A because it loses contact at that time. Okay. So this is the problem we're trying to solve. And it's clear that it's easy to find, or the easiest way to do this is not a force balance, but rather a moment balance about B, because then you don't have to worry about Bx, By. So our strategy is going to be do a moment balance about B. And of course, to do this, we need FAB and FBC. Right? We not only need the magnitude, but we need their location, because I need to know where this force is located in order to find a moment about B. Okay, so I'm gonna just copy this. And because we don't care about B, I'm just gonna remove the B forces. Okay, so this is the problem we're dealing with. And I am going to start with force BC. Okay, so first let's try to find the magnitude of the force. We know force on the submerged plane has a magnitude rho g, h centroid of that plane times the area of that plane. Okay, so first I need depth of the centroid, right? So going back to the problem figure, this is the submerged part of BC, right? I know from the top surface all the way down to the bottom is h, and from B to the bottom is 1. So this part, the submerged part of BC, is h minus 1. Okay, I'm going to call that something like capital H, just to make it a little bit easy for us. Okay, so if that is capital H and it's an unknown we're trying to find, then where is the centroid? Well, again, h minus 1 or capital H is from the surface to B, so half of that is where the centroid is. So that's rho g, h divided by 2. What's the area of that BC plane, or the submerged part of BC plane? It's the h minus 1 times 2 meters into the paper, which I'm going to call 2h. Again, the capital H is just what I'm calling h minus 1. Okay, so this will become rho g h squared. That's the magnitude of this force FBC. Okay. So now that we know the magnitude, let's find its location. So for location, it's always better to draw the cross section of the plane we're looking at, and this is a rectangular plane. I'm showing the plane BC. So this is 2 meters wide into the paper, so that's 2 meters, and this is h or h minus 1, right? So this, again, from here to here is h, 2 meters wide into the plane. Okay. And if this is the centroid, I have an xy plane. You might remember from class, we've done an example of a rectangular plane that the location of the force ended up being 2/3 from the top. It's kind of like a distributive force that looks like a triangle, right? So if you remember that, that's great. If you don't, we can just calculate it, and we have the formula right here. So YR is basically IXC divided by YCA plus YC. YC is the vertical position of the centroid in the plane of the gate, right? In this case, because the gate is vertical, Y is the same as Z, or depth. So it's a bit easier. Okay. All right, so IXC for rectangular plane, you have this in your textbook. It's 1/12 BA cubed. And B here is 2 meters, is this length, A is H, right? So with that, let's just plug in. We have 1/12 times 2 times H cubed. And YC, so what is YC again? Remember, YC is H divided by 2, right? It's this distance from the submerged part to the centroid. So that's H/2. What is the area? The area is 2H. And again, what is YC is H/2. In this case, YC again is the same as depth, just because this is vertical. We know if there's an angle, you have to take that into account. Okay. So if I simplify this a little bit, we're going to get 6H cubed. Sorry, H cubed over 6 divided by H squared plus H/2, which is H/6 plus H/2, and that's 4H/6 or 2H/3. Okay, so basically from here, again, wherever the top of the surface is, to here, this is 2H/3. Okay, and this part from the force to B, that is H/3, which is the part we want if you want to write the moment from FBC about B. Okay. All right. So I'm gonna highlight this. This is the magnitude. I'm gonna need this. And this is the location. All right. Okay, so that's BC. Now, again, I'm gonna copy this and let's look at AB. Okay, now AB is a bit different from what we've seen before. It's actually easier. The reason being, all of AB is at the same depth, same Z or H, right? So if I look at BC, it's going down, which means the force increases with depth. That's why you have the force kind of offset from the centroid, right? But in this case, what do we have going on this AB? You just have a bunch of small forces that are all the same. These are all same magnitude because they are at the same depth, right? So pressure is rho gh at all of those points, which means the force has to be in the middle, right? This is completely symmetric, right? So the magnitude is just rho gh or hc. Again, doesn't matter because the centroid is the same for this plane as any other point. So this is all h c times its area, which is rho g. What's the depth of that point? Yes, it's h minus 1 or capital H. What's the area? It is 20 centimeters times 2 meters into the paper, right? So that's 0.2 times 2. So this is 0.4 rho gh. So this is the magnitude that we're going to need. Where is this force located? Right at the midpoint of AB, which means the distance of the force AB to B is 0.2 divided by 2 or 10 centimeters. Okay. Okay, so now that I know this, the magnitude and location of force AB, magnitude and location of force BC, just going to do a moment balance about B. Okay, if we look at the forces, the moment from AB is clockwise, the moment from BC is counterclockwise, so these two have to be equal and cancel out each other, right? So FAB times 0.1 has to be equal to FBC times H over 3. We have some numbers. For AB, it's 0.4 rho GH times 0.1. For BC, where is it? Rho GH squared times H over 3. We can simplify a little bit, can get rid of the rho G and the H. So what do we get? We get H squared is 3 times 0.4 times 0.1. Hopefully, let's check, let's see if the numbers are correct. We get 0.1, 0.4 times 3. This is 0.12. And H is square root of that, which is 0.346 meters. Okay, or 34.6 centimeters. But remember, H is the variable we defined, which is H minus 1. Really want to find the small h, not the capital H. Right? So small h minus 1 is this much, which means the small h is 1.346 meters. And that is our answer. This is the depth at which the the gate will start to rotate and release water. So this is minimum depth. Anything above this, the gate will start to rotate. Okay, so I hope that is clear. I'm gonna post the solution too, and I'm gonna post a video. Hopefully this is something that we can continue. I'm hoping that I can do this at least once a week. So I can do just like one example from every chapter, every section, starting from this week. Okay, thank you.